Hello, good morning. Today we'll study something regarding vitamin K. Vitamin K is a very important fat soluble vitamin which is required by human body for post translational modification of certain proteins required for blood coagulation and in the metabolic pathway in the bones and some tissues. They are 2-methyl 1,4-naphthoquinone derivatives. Two natural vitamins they are there, vitamin K1 and vitamin K2. Vitamin K1, also known as phyloquinone or phytonadione, is synthesized by the plants. It is found in great amounts in green leafy vegetables because it is directly involved in the photosynthesis. It is also known as plant form of vitamin K. It is active in animals and may perform a classic function of vitamin K in animals, including the activity in the production of blood clotting proteins. In animals, K1 is converted into vitamin K2. Vitamin K2 is the main storage in the case of the animals and has various subtypes which are differentiated on the basis of isoparanoid chain length. These vitamin K2 homologs are also known as menaquinones and are characterized by number of isoparanoid residues in their side chain. Menaquinones are abbreviated as MKN, where M stands for menaquinone, K stands for vitamin K, and N stands for number of isoparanoid side chains residue. Now, very important, bacteria in the colon, that is the large intestine, can convert K1 into vitamin K2, right? The three synthetic form of vitamin K are K3, K4 and vitamin K5. K1 vitamin, the precursor of most vitamin K in nature, is stereoisomer of phyloquinone and is important chemical in green plants where it functions as electron acceptor in photosystem 1 during photosynthesis. For this reason, vitamin K1 is found in large quantities in photosynthetic tissues of plants, that is green leaves, dark green leafy vegetables like lettuce and spinach, and it occurs in small quantities in other tissues like roots and fruits. Vitamin K in animals is involved in the carboxylation of certain glutamate residues in the protein to form gamma carboxyglutamate residues, that is GLA residues. GLA residues are usually involved in binding calcium and are essential for the biological activity of all known GLA proteins like blood coagulation, prothrombin protein, that is the factor 2, factor 7, 9, 10, protein C, S and Z involved in the blood coagulation. Then bone metabolism, that is osteocalcin, also known as bone GLA protein, matrix GLA protein, periostin, and recently discovered GLA-rich protein. Like other lipid soluble vitamins A, D, E, vitamin K is stored in the fat tissue of human body. Recommended amounts: vitamin K for 25-year-old male 120 micrograms per day, for adult women 90 micrograms per day, for infants 10 to 20 micrograms per day, for children and adolescents 15 to 100 micrograms per day. Supplemental vitamin K. Oral dosing is often more active than the injectable dosing in humans. Then supplemental vitamin K promotes osteotrophic processes, that is the formation of bone, and slows osteoclastic processes by calcium binding. Dietary deficiency is extremely rare unless the small intestine was heavily damaged, resulting in the malabsorption of the molecule. Another risk group for deficiency were those subject to decreased production of K2 by normal intestinal microbiota as seen in broad spectrum antibiotic use. That is, those who are taking broad spectrum antibiotics, there the intestinal microbiota is killed, and as a result of which less vitamin K2 is produced. So, taking broad spectrum antibiotics can reduce vitamin K production in the gut by nearly 74% in people compared with those not taking these antibiotics. Sources: green leafy vegetables like spinach, mustard green, parsley, green leafy lettuce, vegetables like broccoli, cauliflower, cabbage, fish, liver, meat, egg, and cereals. Vitamin K deficiency. Average diets are usually not lacking vitamin K, and primary deficiency is rare in the healthy adults. Newborn, in fact, are at increased risk of deficiency. Those who suffer from liver damage, that is alcoholics, cystic fibrosis, inflammatory bowel disease, recently had abdominal surgeries, their vitamin K deficiency is more common. Secondary vitamin K deficiency can occur in those taking anticoagulants. Osteoporosis and coronary heart disease are strongly associated with lower level of K2. Vitamin K2 deficiency is also related to severe aortic calcification and all-cause mortality. So, vitamin K is a very important fat-soluble vitamin obtained from green leafy vegetables, involved in the production of proteins involved in blood coagulation, as well as proteins involved in the metabolism of bones and certain tissues. So, I hope the concept is clear regarding the vitamin K. Thank you.